In the last video, we looked at covalent bonding and how atoms with unpaired electrons can share with each other to create a shared pair, and that shared pair is called a covalent bond. What we're going to look at in this video is a special type of covalent bonding called coordinate bonding or dative covalent bonding. And if we look back at some of the molecules that we formed in our last video, for example, BF3. If you remember BF3, because boron was in group 3, it had only 3 electrons in its outer shell and therefore could only actually make 3 covalent bonds because it only had 3 electrons to share with. We had it with BF3 was our molecule. And so what we notice about BF3 is there is a space for 2 more electrons to get a full shell of 8 for boron in row 2, period 2 of the periodic table. So there is a gap there and there is space to share electrons. And we also looked at a molecule like NH3, ammonia. Now ammonia's nitrogen's in group 5, and so ammonia has 3 shared pairs and a lone pair. So ammonia has spare electrons that it isn't using in bonding already, and boron has a space that it could use in order to create another covalent bond. So what can happen is that a molecule like ammonia that has a lone pair can come and share that lone pair. I just removed that orbital. It can come and it can share that lone pair with the boron, but both electrons in the shared pair are now coming from just the nitrogen. This is called a coordinate bond. And what we're going to do is when we draw our stick diagram, where we would have just had regular covalent bonds with the B and the 3 Fs, the nitrogen is using its lone pair here to create a covalent bond that is coming from just the nitrogen, and so we use an arrow to represent this new dative covalent or coordinate bond that is still a covalent bond. It's just where the shared pair isn't one from each atom. So we're going to have a look at this type of bonding now with a few examples and how we explain this to examiners. So a coordinate bond is a covalent bond in which both electrons of the shared pair come from the same atom. So the atom that donates, so that both electrons of the shared pair from the same atom, and the atom that donates has a lone pair, and then the atom that accepts is electron deficient, doesn't have a full shell, does not have a full outer shell. So that was our B in BF3. So coordinate bonds are shown using an arrow, and the arrow points from where the lone pair is to the electron deficient atom. Once it's formed, it is just a shared pair. So let's have a look at the example. So the ammonium ion. When we take ammonia, the molecule, and we react it with acid, and so like hydrochloric acid, sulfuric acid, they contain a H+ ion. It forms an ammonium ion, and that ammonium ion contains both standard covalent bonds and a coordinate bond. It is then ionic because it is an ion, so it can then form ionic bonds as well. So this has the a full sort of complement of bonding types except metallic. What we're going to do is we're going to draw the dot and cross diagram, then turn it into a stick diagram and see the difference. So nitrogen in the centre of ammonia is in group 5, so we put 5 electrons in the outer shell of nitrogen. It forms 3 regular covalent bonds with hydrogen, and hydrogen only has 1 electron. It shares it with the nitrogen to make 3 bonds, 3 shared pairs. So if I was to draw that as a stick diagram underneath, I'm just going to do it 2-dimensionally. We have a lone pair and 3 bond pairs. Hydrogen ion, hydrogen has 1 electron normally, so the hydrogen ion actually has no electrons, it's ionic. I'm going to put the positive ion in a square bracket. If you go back to ionic bonding, you'll remember that. Those two are going to come together, so there's nothing different to draw actually down here. Those two are going to come together, and the lone pair from the nitrogen, cross-cross, is going to share with that hydrogen. These other 3 shared pairs were as they were before. So this top hydrogen didn't have any electrons. The whole thing is now an ion, charged. And so we've got this nitrogen with 3 regular covalent bonds from before. And where the lone pair was, we've now got an arrow pointing up towards the hydrogen that was from the hydrogen ion that had no electrons of its own. This here is, let me find a different colour that we've not used. This here is the coordinate bond. And if we look back at what we said, we need to have an atom that has a lone pair. So who has a lone pair? Nitrogen has a lone pair. We need an atom that is electron deficient. Hydrogen is electron deficient. And this coordinate bond forms between an atom that has a lone pair and an atom that is electron deficient. That's our coordinate bond. So what we're going to look at is who is electron deficient. And we need to be specific, so don't just say hydrogen, it's the H plus ion is electron deficient. And who has a lone pair? So it was the nitrogen atom in NH3. So don't say NH3 has a lone pair, which specific atom, because the definition says the shared pair come from the same atom. So a covalent bond is formed in which both electrons of the shared pair come from the nitrogen atom in ammonia. So we've got standard covalent bonds and a coordinate bond. So now we're going to have a look at the hydronium ion in H3O+, formed in a similar way when water and acid react. So again, oxygen, it's in group 6. So if we go around 1, 2, 3, 4, 5, 6, 2 regular covalent bonds to hydrogen. Two lone pairs. So we've got lone pairs on the oxygen. We've got a hydrogen ion, so no electrons, that's electron deficient. And so what we're going to do is use the lone pair on the oxygen to form, oops, this is supposed to be a dot and cross diagram, so let's just try that again. A coordinate bond to the hydrogen ion. So we've got an oxygen with 2 covalent bonds and 1 coordinate bond, still got a lone pair, and the whole thing is now charged. So we had the electron deficient atom here, the atom with the lone pair here, and our coordinate bond has formed here. So who is electron deficient and who has a lone pair? So the H plus ion is electron deficient. The O atom in water has a lone pair. So a covalent bond is formed in which both electrons from the shared pair come from the O atom in H2O. Now sometimes students wonder whether this hydronium ion now with its lone pair, so this is the new hydronium ion that we've formed with its lone pair, could form another coordinate bond to another hydrogen ion. Well, the answer is no, simply because this hydronium ion is positively charged, and so it wouldn't attract another positively charged ion. The two would repel each other, and so they wouldn't be able to form a second coordinate bond. Our last example is AlCl4 minus coming from AlCl3 and Cl minus. So if I think about AlCl3, now from the context of this question, aluminium chloride we're going to take as covalent. I know it seems that it has a metal and it should be ionic, but actually aluminium, if you think about its position in the periodic table, it actually lives on the other side of the periodic table with the non-metals. It has both metallic and non-metallic properties. Aluminium can form both ionic and covalent compounds. It forms a covalent compound with chlorine. So we're going aluminium's in group 3, 1, 2, 3, and it's going to form regular covalent bonds with 3 Cls. And we can see that it's electron deficient because it's got a gap down here that can fill with some more electrons. Now, a chloride ion is a Cl with 1, 2, 3, 4, 5, 6, 7, and then an 8th electron I'm going to draw as a triangle coming from another atom. Maybe it came from NaCl. That may be where we got our chloride ion from. And that's a 1 minus ion. So in terms of a stick diagram, we've got an Al with 3 chlorines on it and an empty space, and then we've got a Cl minus ion. So what have we got when we've put these together? We've got aluminium here with its 3 electrons. Forming 3 regular covalent bonds to 3 Cls. And then we've got this extra chlorine, and it doesn't matter which pair of electrons you use from the chlorine. The point being that it has 2 from the same atom, and the whole thing is now minus. So we've got a lone pair, lots of lone pairs on the Cl. So who's electron deficient this time? Well, actually the Al atom, we can just write the Al in AlCl3 is electron deficient, and the Cl minus has the lone pair. So a covalent bond is formed in which both electrons of the shared pair come from the Cl minus ion. So this is coordinate bonding.